everyone. I am A.S. Reddy, Assistant Professor in the Department of Computer Science and Engineering. So I am going to share my views based on the open CV, that is Computer Vision Library. So in this Computer Vision, we are going to see the basics of what is Computer Vision and how it is implemented in systems using deep learning. Let us go to the slides. In this session, we are going to see the introduction of computer vision, introduction to deep learning, then the role of deep learning in computer vision, then the demo, how the neural networks is linked to the computer vision, and how it is related to the images. Then the demo related to CNN models, then the demo related to pre-trained models and prediction, then the demo related to transfer learning for future extraction. Oh, next. While coming to the computer vision, I want to share the few examples because nowadays computer is involved in artificial intelligence that act as like human brain. How does a computer work like a human brain? This is regarding the image. Till now we are known about the data processing, how the data is processed and how we get the information that are related to our words. Now there is an advancement in the technology that is using images. We are going to learn the concepts. We are going to identify few techniques and we are going to implement these image learning concepts in our learning and other examples. Example, let us take the image processing like object abstraction learning. Then computer vision is the science and technology of machines that see, that are viewed by the how a human is viewing a particular object and how does a computer view the particular image. So these are to be learned in this open city topic. Then, concerned with the theory for building artificial systems that obtain information from images. That is, we are going to deep learn the images. Okay, each and every image we are going to deep learn and how it is trained by the computer. And from that training, we are going to obtain the knowledge or information. The image data can take many forms such as video sequence, text images, views from multiple cameras or multi-dimensional data from a medical scan. So, wherever it is used in a medical field, then wherever the image is required. For example, till now we used to search the internet through words, right? Information if you want to get from the internet, we used to type the words. But nowadays, we are having the facility of giving an image. For example, if you take a snap of your tree and go to the Google, how does it reply now? It will search the tree from root to top and it will give what type of tree it is, what are the features of that particular tree and what is the lifetime, everything. Each and every detail will be given by that particular image. From that particular image, we used to get all the details. We need not go and search for the particular leaf size or the root, the span of time, everything. It will say, completely it will say about the particular image. That's what we are going to see here in computer vision. Then comes the how does an image is learned by a computer? What does it learn from an image? Here is an example. What kind of scene it is? See, take this picture. Here we are having a house, car, trees, then a dune, then extra land on as well as a cloud and all. But what we see is different from what a computer sees. So it will see how many colors are involved in this, what is the depth, and how many pixels are involved, what is the range, everything it will be recorded using the computer scene. Okay, see how. This is how the difference between human vision as well as the computer vision. See, we used to see a particular image as a building engine, then staircase, ladder, like that we used by seeing this particular image. But a computer sees the everything as zeros and ones, and it will be related to the matrix format. Okay. Here it will be recorded inside a computer as the numbers, numerical values. So from this numerical values, we can obtain the required knowledge. Then vision is really hard. For example, my perception of a particular image will be different from your perception. The same thing will be followed by a computer also. So what here we are doing, we will collaborate all the information that are obtained from a picture, and we will incorporate what the information are being needed. So here for a particular picture is taken, what I am going to see now, that my visual cortex, how much it is there, and how a human brain will think related to that. So all the training will be given to the computer based on the human vision. Then comes your multidisciplinary vision. How the multidisciplinary vision will be taken inside a computer. Okay, for example, here artificial intelligence, robotics, signal processing, computer graphics, imaging, neurobiology, then mathematics, all that involves the computer vision here. So what they do in computer vision actually, they take a particular image, they split into multiple diagnostics and how it is involved as well as, for example, length, breadth, depth, then what is how many pixels are involved, and how those pixels, what they convey, everything is read by a computer vision. Next comes here, where and all it is applicable. The computer vision, where it is applicable, and from that computer vision, what we learn as an information. See, for example, road safety. So they need to know how a car image to be captured, then how an accident occurs, how they are able to reveal the pictures from the captured images. Then healthcare and all minute difference between the images. What, for example, scan or X-ray. From that particular image, what can be read? So it is mostly involved in cancer studies. Okay, or the tissue growth, then multiple stages of the cancer, everything is obtained through these scans and images. Then comes your security. In security cameras nowadays is very well advanced, and here we use the computer vision technology, how the particular theft or security is related to one image, previous image to the current image. How it is differing, and from the face recognition and all is done by computer vision. Then in comfort, for example, cartoon pictures and all uses computer vision technology, and it is used there also. And games. Gaming and all nowadays it is real-time gaming has come, and our image itself is taken as a player, and we are playing many games in that area also. Computer vision is involved. Then access, where normally when we log into our email or any account related to computer, we use to type our password. Nowadays it is not necessary as such. If you show your face, it will be recognized, and it will give the login access. So the same way in everywhere you will find nowadays iris recognition or face recognition or image recognition is involved more than login images, login words. Next comes the examples. See, by how the scanned image is converted into data. So the actual work behind computer vision is that an image is learned thoroughly, and from that image we are converting the image into data. See here we are having the image, and from that image I have transferred my image into a data, useful data, and these data will be processed based on the requirement. One of the most important applications where we see in real time is that face detection. Nowadays, you can see that camera when you are using a mobile or the camera, digital camera, it will automatically recognize your face and it will say it in a square. So this involves the computer vision technology, and that is the image processing is involved. That is where the image processing is involved. In smile detection. So in smile detection also we use the computer vision technology. Then comes the object recognition, that is barcoding or the image, whatever the picture you scan, that will be taken and it will be processed and it will convey you whether the particular process or the particular product is available or not. Then biometrics. In recognition of your iris or the face, that will can be done using computer vision. As I told you earlier, the login password is replaced by face recognition. Special effects in both cinema and other media. It is done by computer vision. Not only in still images, we can also use computers in motion pictures also. That is an example. We are having the picture of an octopus and a man, then both are combined and we get a new picture. So here computer vision is used by detailed study of image processing. We are combining these two and it can be used in motion pictures also. And in sports, hope you all aware of seeing cricket or any other game, football or anything, being foul or any out is given, and if you want to get the exact incident about that, if you want the exact detail about that, we are going to deep into the camera picture and we are going to learn pixel by pixel, and that image will be given exact result. So for that also OpenCV is used. In smart cars nowadays, every vehicle is having the motion capturing. There is objection is recognized by the car itself. I think in self-driving cars, this is a major part in self-driving cars. That is a Google car, what I told you now. Then vision-based interaction gaming involves the OpenCV. Then in the medical field, when scan images, pixel by pixel, you can read the content of the cells. Visual question and answering, the quiz what we have conducted. Then these are the places where we use OpenCV in real time.